we want system turn down and multiple boilers, because if we got 3 boilers at 33% fire rate running versus 1 boiler at 100% fire rate, we're going to be a lot more efficient with condensing boilers. We can push you towards that 99% efficiency if I got high turn down and I get cold water coming back and I make sure I got running multiple boilers at reduced fire rate. This is why this idea of cascading the systems makes sense. And most of your major condensing boiler vendors have a master control setup where they can run multiple boilers and run them on down at low fire to increase efficiency. And we would strongly recommend whoever you go with that you buy those and take a hard look at them, because that's the key to getting efficiency of these systems. You're paying the money for variable speed. You're paying the money for condensing boilers. Codes are driving you that way. Let's make sure we take full advantage of it. In the old cast iron boilers of my generation, 40 years ago, we used 3-way valves. We had pretty much constant flow through the systems. They were big old cast iron boilers. They had hundreds of gallons of water in these big old cast iron boilers. They were huge. You go in the equipment room, they filled the whole room up. It was unbelievable how much water was in these things. We normally designed them on 20-degree delta T, so we had pretty big pipe, pretty high water volume. We didn't have the outdoor air reset numbers we got today. We had outdoor air reset, but it was nowhere near as much outside air. We would not. It was slow changing, so it was much easier to adjust on. The controls on these things are very simple. Most of the big old cast iron boilers had a simple Honeywell strap-on or insertion aquastat on them that maintained the boiler at some number, 150 degrees. So all the water in the boiler, there's hundreds of gallons of water in the boiler, 150. You didn't have any condensing problems. They kept them hot. They were simple. That was really simple. Now, specific heat, I bring this up because you know what it is. I want to get fundamental. And on the next slide, I think it's actually more important than this one. I'm just defining specific heat here. Let's look at the numbers for water. If I look at water, by definition, specific heat being 1 BTU is going to raise a pound of water 1 degree. So if I got a gallon of water, 8.33 pounds, then every 8.33 BTUs of energy I put in a gallon of water, that gallon's going to come up 1 degree Fahrenheit. And I don't care whose boiler it's in. I don't care where it is. It's going to be the same all over the world. That's a message you need to understand that. What's happening with the new systems? We talked about the old ones. This is the point I want to get across to. The new systems, we're going to 2-way valves, right? The code's making us go that way. 90.1 says you got to vary the flow. We haven't go to 2-way valves. We got variable flow system. No questions asked. We made that change. The new boilers, though, have smaller heat exchangers, particularly the water tube boilers, really small. You may have a 800,000 BTU boiler that may only hold 10 or 12 gallons of water. There's just no water in there. Very low water volume. But these are ours as well. Very low water volume. We're going to higher delta T's on the design. We're no longer using 20. I see 30 about everywhere. I see a fair amount of 40-degree delta T. Why? We want cold return water temperatures on our condensing boilers to get the efficiency up. We want cold return water. It means your pipe sizes are smaller. It means there's less water in there, less volume. So your pipes are smaller. The boilers are smaller. Begin to see a problem here. Fast changing loads. Now we got these sensors. We got a bunch of people in the room, and they come in the room. All of a sudden, they want so much outside air per person. So you quickly open up a damper to bring in outside air. So we got fast changing loads based on this new outdoor air requirements. And we expect our boilers and our systems to sense this quickly. That's what we're talking about, quickly, and respond. We also got more complicated boiler staging, and we're trying to modulate temperature control. So it's everything has gotten more complicated in newer systems. We've got to tie all of this together to make it work properly. Let's go back to my gallon of water. I'm trying to insult you. I want you to realize that a gallon of water in anybody's boiler is still a gallon of water. So if I put 8.33 BTUs in it, it's going to come up 1 degree. So here's what I'm trying to take you to. Let's take a typical system, and let's just use 180 as a set point. Set point could be 140, could be any number you want. How do you turn a system on and off? What is true delta T for the boiler in a system, and how does it set up? So let's just take a look at a modern boiler setup and make sure we kind of understand what's going on. Let's just take a set point of 180, And let's allow 12 degree delta T total. Well, that means if you look at the set point of 180, and again, it could be any number you want to. I'm just taking number 180. If my set point is 180, I'm sensing supply water temperature to the system. As that number goes up, my fire rate comes down. In other words, if the set point is going up to 182, I'm taking the fire rate down, on down, on down. And I've got to take it off somewhere. In other words, here's what's going on. If the boiler is putting more energy BTUs into the system than the load is taking out, then the supply temperature is going to do what? Start going up. And sooner or later, you've got to take it offline. So we're saying at 186, I'm taking everything off the line, that my boilers are putting more energy into my system than I'm taking out, so the supply water temperature is creeping up. And as it goes up, sooner or later, I can't keep on doing that. I've got to take it offline. Now, if I'm matching the load with my boilers, if my boilers are firing at a rate that is exactly equal to the load of my system, which they're good at, my set point being 180, I can hold that set point pretty close. I can hold it 180, maybe half a degree, right? I can hold a nuts on that as long as I can modulate and put the BTUs into the system that you're taking out. So what I'm talking about is what happens when I'm putting more BTUs in the system than you can take out, and your temperature starts rising. Let's go to the other side of the set point. If I'm taking more BTUs out on the heating side than my boiler is putting in, what's going to happen to my supply temperature? It's going to start dropping. So sooner or later, as it drops, I'm going to have to bring another boiler on, stage another boiler. I'm going to be at full fire. So basically, I'm going to stage another boiler. So if I were to keep dropping there's going to be this cold water temperature that tells me I got to bring on another boiler. So I'm looking at a 12 degree on-off situation here, basically, so you kind of understand. I'm looking at 12 degree delta T, and when I drop to 186, I'm cutting everything off. If I get to 174, I'm adding more. And as long as I match everything, I'm about 180. So that's kind of the idea behind this delta T thing that you need to understand, because we have to size tanks. We've got to look at volume. So let's take a look at this thing. If I had a 2 million BTU fire boiler, typical 2 million BTU boiler, and I don't care if it's primary, secondary, or variable primary pumped, every boiler has to be started. And if you got a 2 million BTU boiler, and let's say that's the startup fire rate's 2 million, let's see what the start fire rate may be. In this case, I'm saying 30%. In other words, I'm saying I don't care what the turn down is on your 2 million BTU boilers. Most boilers will not start at turn down. Let me repeat that. Most boilers will not start at the minimum turn down. What am I saying is, you're turning a 2 million BTU boiler on. You've got to go through a purge cycle. You've got the fans that are going to come home, make sure there's no natural gas, and make sure everything is, all the air is in there. They're going to test all the controls. Then you're going to fire it up and get everything hot, and then you start modulating down. And that doesn't sound like it takes very long, but it can take 40 to 50 seconds easily. Let's assume it only takes 30 seconds. Now, you please stick with me, because this is one of the major issues we've seen with these boilers at low flow rates, and I think you need to kind of get it in your head, please. If you do this and you have a 2 million BTU boiler, and let's say at startup, it starts off at a fire rate of 30%. To be honest with you, most of them start off with a fire rate higher than that. Doesn't last long, but you don't start at the modulation reduced rate. You start at some fire rate based on the controls. So if I got a 2 million BTU boiler firing at 30% fire rate for 30 seconds, how many BTUs is that? It's 5,000, as shown on the slide. 5,000 BTUs you generated in 30 seconds. What could happen in 30 seconds? What could happen in 30? Sounds pretty easy, doesn't it? I don't care if it's variable primary pump, it's the same issue. I've got 5,000 BTUs I'm putting in this boiler in 30 seconds. At startup only. I can modulate down after startup, but I've got to get it cranked before I can modulate down. I've got to start it. So what does that mean? Well, supply temperature sensors and the temperatures on these boilers, they all have to have some time to work. On a direct sensor situation, I'm using 30 seconds. In other words, between the fire rates and the temperature I'm seeing and the response time of the boiler, I'm saying 30. If it's an energy management system, building management system, it could be longer. It could be 45 to 60 seconds. You can take any number you want here, but these are very conservative numbers. I'm telling you, between the time you sit on the boiler to fire up and get going, There's some period of time before it gets under control. It takes a while to get it under control. So what happens in this 30 seconds is kind of the question. Let's just say we had very low flow rate through the boiler. Let's just say the boiler had no volume of water in it. No volume, maybe 10 gallons. Can't even really count it. No volume of water in the boiler. Very low flow rate of 10 GPM. What would happen in the boiler in 30 seconds? Think about it. What would happen? Let's go back. So every boiler has a minimum flow and a minimum system volume. Your boiler operating goal should be to do what? Fire for a minimum of 5 minutes, dry out good, run for 5 minutes, and be off 5. We want to make sure we don't hit this manual high limit safety, normally set at 210. The green safety control is a manual high limit, and we don't want a short cycle.